All right, hopefully everybody can hear me okay. This is a catch-up lesson, if you will, on global warming for the folks that are at IASIS. And had a couple folks at the Jane Goodall talk as well. So hope the tournaments are going well and the talk's going well. And let's talk about global warming. I sent everybody a clip, and it's a clip about Al Gore, and he talks about the relationship between carbon dioxide gas and global temperatures. And he used what's called the ice cores in the Antarctic, and I'll talk about that in a minute, to show a relationship between those two. So if you could, maybe hit the pause and watch that little 10-minute video, come back, and I'll talk you through this. Okay, so for starters, the temperature of the Earth is increasing. That's indisputable. Everybody has accepted that, and there's data to prove it. The temperature is going up. What all the talk and hype is about why is the temperature going up. And so what I've listed here are possible causes of global warming. And the one that I think at least deserves the most credit and time is what's called the enhanced greenhouse effect. And what that is, it says that increases in greenhouse gas contributions from anthropogenic sources or man-made sources are what's causing the temperature to go up. But I don't know what you want to call them. They're not really global warming skeptics because it's accepted that the Earth is getting warmer, but um, greenhouse gas skeptics would push the idea of solar flare activity, and what that says is the idea that there's an increase in um, energy from the sun because of an increase in solar flares in the past 100 years, and they feel that the temperature increase is caused by that. You have volcanic activity is an increase in CO2 levels because of volcanoes, and this one, hesitate even to write it down, a change in the Earth's axis. You know what, maybe we should just stick with those three, the first three. So, Al Gore talked about ice cores, and here's how an ice core works: is you have a glacier, and like this glacier down here, and above the glacier you have atmosphere, and that atmosphere contains carbon dioxide and ozone. And the concentration of ozone is dependent on the temperature. And so what happens is in year one, you have carbon dioxide and you have a set amount of ozone based on the Earth's temperature. The snow falls and some of the carbon dioxide and ozone gets trapped in there. And then in year two, you have carbon dioxide and you have ozone. The snow falls again, and it gets trapped in as well. And so what they do is they produce. You can just see here how this is building year one, year two, up to basically this graph goes back 400,000 years. They have data up to 600,000 years, which measures ozone concentrations, which is related to temperature, and CO2 concentrations. And so when you take those ozone concentrations and you map it against temperature, you get a graph that looks like this. The blue line is the temperature variation, and the red line is the carbon dioxide concentration. And as you can see, as anybody can see from this picture, those two are definitely related. Okay, carbon dioxide levels are related to global temperatures. So, again, that's undisputed. What's up for argument, if you will, I guess, is the question of which is the cause and which is the effect. Is it an increase in CO2 levels warm the planet, or is it a warming planet increases CO2 levels? And unfortunately, in my opinion, it takes immediate data to show that, and I think that data will come too late to do anything about it. Hence the current concern. All right, CO2 levels right now are the highest they've been in 600,000 years. All right, so if it is in fact the case that carbon dioxide determines global temperature, then we have the highest CO2 levels in the past 600,000 years. What would naturally follow that is the highest global temperatures in 600,000 years, which is a worry. So hence, let's look at the sources and the sinks of carbon dioxide. What puts it in the atmosphere? What takes it out of the atmosphere? Well, it's in the atmosphere primarily from burning fossil fuels. That is our main way that we put it into the atmosphere. Volcanoes also contribute to carbon dioxide, as do cellular respiration. Now, again, people will say, oh, well, volcanoes contribute to carbon dioxide, and that's not a anthropogenic source. But my argument would be volcanoes have always been here. Cellular respiration has always been here, and now we have the highest CO2 levels in the past 600,000 years. What's different? Us. We're different. And we're the ones that dig the oil up out of the earth and burn it to put the CO2 in the atmosphere. Um, Carbon dioxide sinks include photosynthesis and the oceans. Just like a can of Coke, the oceans can dissolve carbon dioxide in it and are doing so. So I have this beautiful diagram. You're going to love this. Okay, art students, no judging. You have a car producing CO2. Yeah, that is an awful diagram. A car produces CO2, okay, which is then the source is then used up by the sink, which is the tree and the ocean. Okay, but here's the issue. Just like a glass of Coca-Cola, if you leave it out and it warms up, you come and drink it, and the Coke is flat, and it's because the solubility levels as water warms, the ability to dissolve CO2 decreases. And so the same thing could be said about the oceans. As the oceans warm up, they are less capable of dissolving CO2, and really you could hit a point where carbon dioxide sink, which is the current ocean, becomes a carbon dioxide source, and actually emits carbon dioxide into the atmosphere. The other issue is this: our friend here with the axe chopping the tree down. It's not one tree, it's millions of trees. And I mean, I understand that, yeah, we need to do this for the economy, but we also need to replace it. When you're cutting trees down, you have to replant, and we're not doing a good enough job of that. Deforestation removes carbon dioxide sinks. And so we have a mechanism. Let me talk you through cold, dry facts how this is proposed to work. The sun, as we learned a couple of days ago, is a constant energy source. That source is 1400 watts per square meter. And so with the albedo and the light scattering and the greenhouse gases, you get an equilibrium. Remember, we talked about thermal equilibrium last year. Well, those factors all establish an equilibrium, which essentially leaves the Earth at a constant temperature. And what we've done is we've increased the greenhouse gas concentrations, so now the Earth is shifting towards a new balance, a new equilibrium. And that new equilibrium will be a higher global temperature. So what does this warm temperature do? Well, we talked about the oceans, and so if you warm up the oceans, this carbon dioxide sink becomes a carbon dioxide source, and it will start to release CO2 into the atmosphere, therefore increasing the greenhouse gas concentration and making the planet even warmer still. You also need to consider the polar ice caps. And we've all seen the picture of the polar bear that's swimming into the abyss of open sea, and there is reality in that, but really on a climate level, polar bears aren't the concern. What's the concern is the albedo. We talked about albedo of snow and ice. When you go skiing, you need to wear sunglasses because the snow and ice is so reflective. It absorbs very, very little energy. And the albedo of ice is 0.85. However, the albedo of water is only 0.1. And so if we melt the polar ice caps, you take a significant portion of the Earth's surface, which is very reflective and absorbs very little sunlight, and you suddenly make it hardly reflective at all, and it absorbs a lot of energy. If the Earth absorbs more energy, the temperature is going to go up. And so, with that, we have an increase in sea levels. The increase of sea levels comes from two things. It comes from land ice, okay, not icebergs floating in the water. That won't change the sea level. But ice on land, as it melts, will flow into the ocean and will change the sea level. You also have to consider something we learned about last year, which is volume expansion, and the idea that a material, when it heats up, it expands. Remember this equation: change in volume equals the coefficient of expansion times the initial volume times the change in temperature. The same physics applies to the ocean. As you increase the temperature of the ocean, your initial volume of the ocean will increase with it. Okay? So, here's the issue. Here's why sea levels are a concern. This is a map of population density. And this is what ties the environment to economics to politics, and really throws out the argument of, oh, well, you need to worry about the economy, you need to worry about political stability. Well, they're all linked together. As you can see, most of the people on Earth live fairly close to the ocean. Okay, so if the sea levels rise, they can't live there anymore and they have to move. And so we're not talking about thousands of people, we're not talking about millions of people, we're talking about billions of people that need to move. And the issue is, where do we put them? As you can see, we're 7 billion people. We're almost working to capacity right now. There's a significant amount of open space in northern Canada, but you can't put 1 billion people in northern Canada because it's too cold. There's not enough food. Same thing with Siberia, same thing with the Sahara Desert, same thing with the Australian desert. It's a lot of open space, but there's no food there. You can't put refugees there. So you have a problem. You have refugees on the move and no food to feed them. That's an economic crisis. It's also going to be a political crisis, because as those refugees move, where are they going to go? Well, they can't stay in my house because I don't have room. So where do they go? You have a problem. You have basically wars. So it is something that does need to be considered by politicians, by economists, by everyone. So what are we going to do about it? And as I said in class, this is where you guys come in, because you're 18 years old and you're smart. Okay, I'm 40 years old and washed up. I'm going to be doing this for the rest of my life. You guys can do anything, and it's time to step up. We need you. We need your ideas. You are the most influential people on the planet because you're young and you're educated. And so here's a list of things that we brainstormed in class which could help with the global warming individually. Okay, you could recycle or you could reuse, but I put it in big capital letters. The big thing is awareness of consumption. You need to really consider, should I buy this? Do I need this? And the resources that it came from. Public transport. Okay, we have if you look around KL, there's a lot of single people in single cars. Okay, Ina made the point in class that there's one car for every one person, including babies in Malaysia. That's ridiculous. It's time to start using public transport, and it's time to start carpooling. And when you do that, the government will work to improve it. Awareness of energy in homes. Be conscious of what you're doing with the lights. Remember, they're only 10% effective. Air conditioner is the same thing, and if you're not even in the room when the lights are on and the air conditioner is running, well, now it's 100% inefficient. It's a total waste of energy. As a society, okay, we need to research alternative fuels. I was saying, when DVD players first came out, they were almost $1,000, and now you can buy them for $50, and it's because of research and development. The same thing can happen with alternative energy, but we need to put the money into it. We need to educate people. They won't change if they don't understand there's a problem and they don't understand the magnitude of the problem. We need fuel-efficient transportation, and when we cut down forests, we need to replant them. Okay, and finally, I have no idea how I'm doing for time, but government treaties. Okay, the Kyoto Protocol is a fantastic document which is legally binding, reduces greenhouse gases, and allows for economic growth. The only issue with the Kyoto Protocol is that the world's two biggest polluters, that being the United States and China, didn't sign it. And so if you don't get the biggest polluters to sign it, it's not that effective. And I added in my own little embarrassing fact. It's not on the IB exam, but Canada is considering, or maybe has backed out, and that's a real problem, and on a personal note for me. Asia-Pacific Partnership in Clean Development. Everybody loves this. India, China, USA, they all love this idea. It's got all the biggest polluters on board. The only problem is it's basically a pinky swear. There's nothing legal about it. It just says countries saying, yeah, we need to do something about this, and they're not held to it. So that's the global warming in a nutshell. It's quick, so hopefully it all fits on the YouTube. Hope you had a great tournament and a great time at the Jane Goodall Talks, and we'll look for you next week. Take care.